Hi everyone, thanks for being here. Take a moment to think about everything you achieved with computers this past week. For me, it was waking up to alarms, messaging friends across 5 different apps, navigating transit systems, paying for lunch, signing a work contract, and even securing a sauna spot after tracking my workout. Living an analog life in Zurich or anywhere else in Europe? Sure, it is possible, but so much of our lives have moved into the digital realm that I simply don't want to miss out. But here's what bothers me. I seem to need an app for everything now. Every business wants me to have an account with them, to sign up and fill out some form, and more of everyday life is being mediated through these individual apps. And my screen time just keeps growing. Some days I feel like moving from a small screen to a medium sized screen to a large screen to a very small screen, and on and on and on. These screens constantly demand my attention. And I'm not even talking about how they entice doom scrolling, just so I have another very fun fact to tell my friends the next day. Is this what computing was supposed to be? Steve Jobs called computers a bicycle for the mind, tools that amplify human capability. But what if I told you that we could be approaching something radically different, where the next phase isn't about better apps or more immersive experiences, but about computing that could fade into the background entirely? For the next 20 minutes, let's trace how we got here and where we're heading. I'm Alex, usually a computer scientist at ETH Zurich, and it's an absolute pleasure to be here with you today. This is From App to Ability. Back in the 1950s, computing meant number crunching, and it was accessible only to trained professionals. Programmers like Marilyn Westkoff and Ruth Lichterman, pictured here with the ENIAC, studied wiring diagrams and worked for days in trial and error. But all this changed in the 60s when pioneers like Doug Engelbart started reimagining interfaces. In December 1968, Engelbart gave what became known as the mother of all demos, 90 minutes of real-time, interactive and networked computing that wouldn't become mainstream for decades. His team invented the mouse, demonstrated hypertext with clickable links, showed video conferencing between locations 30 miles apart, and even invented the computer Windows. The audience rejoiced in standing ovation. But here's the thing. Engelbart wasn't just showing off cool tech. His team had a new philosophy. Computers should augment human intellect and not just calculate faster. Today, Hornbeck and colleagues define the question underlying human-computer interaction as this: how can people with different goals and capabilities and in different contexts be able to use computing productively, enjoyably, and safely? I want you to keep that question in mind, because every era of computing has tried to answer it differently. Let's investigate this evolution through these two key dimensions: presentation, so how interfaces appear, and control, so how we tell computers what we want. The first personal computers were entirely standalone. You sat at a desk, stared at a screen, and everything happened in that one rectangular window. The interface tried to recreate the physical office by introducing folders, trash cans, and pinboards. Today we call this geomorphic design. So for control, everything was explicit. Move the mouse, click the button, type the command, hit save. The computer did nothing unless you explicitly told it to, in exactly the way it expected it. This opened up information through dial-up and broadband internet, but computers at the end remained tools you sat down to use, and not something that really wove into your environment or understood your intent. So what now? In 1991, Mark Weiser at Xerox PARC published a paper imagining a different future. His famous opening line said, "The most profound of technologies are those that weave themselves into the fabric of everyday life until they are indistinguishable from it." Weiser imagined hundreds of computers in a single room: centimeter-scale tabs, decimeter-scale pads, and yard-scale boards, which together shared a shared infrastructure embedded in the environment. He called this term calm technology. So technology that informs but doesn't really demand focus or require you to operate an interface. His example is quite visual. Instead of checking a dashboard for network status in a web browser, why not have a piece of plastic hanging from a motor that moves with network traffic? The information would just be there, peripheral, and available when you needed it. You'd remain present in your physical environment, but were empowered by the technology quietly working alongside you. Ubiquitous computing is not about disconnecting from technology. It's about technology that doesn't bombard you with content to consume or interfaces to operate. You stay present in the world, but augment it. This was radical thinking about both dimensions. Presentation would move from standalone screens to computation distributed throughout the physical space, and control would shift from explicit commands to implicit awareness. The technology would sense context and ask you and inform you without actually being asked. But here's the reality: we actually never got there. Weiser did predict wearables, Internet of Things, smart home, and those exist, but we didn't invent calm technology. Technology instead became loud, demanding, notification heavy, and that brings us to what actually happened. The iPhone in 2007 made a different bet. It moved presentation by making computing mobile. So now the screen went everywhere with you, and multitouch gestures made interaction feel direct and intuitive. Pinch, swipe, tap. You manipulated the content with your fingers and not an intermediary mouse. But in terms of our dimensions, smartphones doubled down on the standalone screen model and made control even more explicitly app-centric. There's an app for that campaign from 2009 fundamentally shaped how we still think today. Every task should have a dedicated app, and this even became a cultural phenomenon, as you know. It was even featured in a Sesame Street song. This is a fun fact. But fundamentally, we ended up with hundreds of isolated apps, each requiring explicit interactions and living in their own silo, competing for our attention and your personal screen. Siri launched in 2011, Alexa in 2014, and represented the first real shift in the control dimension. Instead of clicking through menus, you could now speak naturally. I mean, sort of. Early voice assistants required pretty strict commands like set a timer for 5 minutes or what's the weather in Hamburg. Alexa advanced things by enabling developers to write what they called skills. This intent-based system is the reason why Alexa could operate so many smart home devices before a standard like Thread existed. But you still needed explicit invocation like Alexa, ask my Nanoleaf to set my Aurora red. Then came language models. ChatGPT reached 100 million users in 2 months, and by September 2025, so just 2 months ago, 700 million active users a week. All because computers finally adapted to how humans communicate in their natural language. You can be vague, you can use pronouns, and you can build on previous statements. The system, if unsure about what you're saying, infers your intent, even if it might get it wrong. But at the end of the day, it still lives in a chat box and doesn't really connect to the real world, at least for now. And then maybe some of you remember all these companies that were trying to shoehorn generative AI into standalone devices and failing. So we had the Humane AI pin, Rabbit R1, the Friend necklace, I could go on. Besides the poor battery life and sluggish performance, trying to replace smartphones as the go-to personal computer, I guess, requires more than just shoehorning a camera, microphone, and cloud storage onto an LLM. So with chat and voice assistants, we are making progress on implicit control, but presentation is still mostly detached from our surroundings. To see movement in the presentation dimensions, we should maybe shift our attention to extended reality, which brings computing into the physical space. Augmented reality traces back to the 1940s in heads-up displays for pilots that overlaid information on the real world. And virtual reality got revived when Paul Malarkey built the Oculus Rift in 2011. These represented two ends of the reality-virtuality spectrum: AR augmenting reality and VR replacing it entirely. Today we're seeing convergence from both sides towards the middle. Microsoft HoloLens and Apple Vision Pro launched with incredible technical capabilities, but faced challenges with weight and comfort. No one really wants to wear them for a long time. And Meta Ray-Ban smart glasses show the lightweight path, focusing on voice and world sensing first, spatial rendering and gestural input second. What's happening here is that presentation is finally moving from standalone screens to situated interfaces, so information appearing in the physical space anchored to the real-world context. But control is still mostly explicit. You still need to do gestures, move your eyes, tap, or speak commands. Looking at this path, we've made progress on both dimensions, but unevenly. We've gotten better at making presentation mobile, and we are starting to make it situated. We've started making control more implicit through natural language, but at the endpoint, we haven't achieved this vision of ubiquitous computing and calm technology. So let's have a peek at how research is making breakthroughs that could get us there, maybe. First, computers are getting better at understanding physical space. Early computer vision could spot objects, and today's systems do panoptic segmentation, which labels every pixel in a scene. Tomorrow's systems can even understand 3D space through natural language. Scan your room and ask for something comfortable I can sit on the other side of the table, and the computer highlights option it's never been trained on. This is already being sought after in research. It works. Second, computers are getting better at observing how you interact. For instance, recent breakthroughs in Bayesian input decoding let computers detect touches on any flat surface using just camera vision from your headset. They can sense your facial expressions even while wearing a headset, and this flexibility means that we can place interfaces anywhere and let you interact naturally with your hands, eyes, or whatever makes sense most to you. And third and finally, computers are getting better at understanding how you think. Using frameworks like computational rationality, researchers can simulate everyday human behavior, from how you type to how you move your hand or head trying to reach a target, and how you search for your parked car. Fine-tuned large language models have recently even been shown to recreate human behavior in psychological experiments they've never seen before. So when you're running low on yogurt, future systems could maybe predict you'll buy more, not from programmed rules, but by just modeling what you might want. So these three research areas converge: world understanding, human sensing, and human modeling. And together they provide the technical foundation for computing that's truly situated in our environment and truly implicit in control. So what could this actually look like in practice? This is the fun part of the talk. Let me walk you through a day in my ideal post-screen future, and I invite you to close your eyes. It's almost like a meditative state, and just let your imagination play. You wake up and put on your glasses. As you gaze outside the window, a subtle weather forecast appears in your peripheral vision, not demanding your attention, just there if you need it. 18 degrees Celsius, Hamburg, cloudy weather, no rain expected. You head to the kitchen to grab some yogurt, and your glasses notice that you're running low and quietly add it to your shopping list without you saying anything, without any interface appearing. As you enter the tram, a ticket is automatically issued based on your location and routine. You flick it with your finger to open the daily news, scrolling through headlines that float in your field of view. You arrive at university and attend a lecture where the professor shares a visualization of neural networks. The content floats in the shared space. Everyone in the room sees the same 3D model, but you can temporarily manipulate your own version, zoom in onto details. And the OS records all of this so you can watch it later. After class, you head back to prepare your code.talks 2035 presentation. The OS gently dims your surroundings. Not completely, but just enough to reduce distractions. Notifications are silenced. The content you need appears organized in the space around you. Your outline on the left, research papers spread on the table, and timer counting down on top. When you finish, the OS gives you a quick briefing of what happened in the meantime, showing you statistics and that you're running late with a meeting in your friend in Bucharest, so you can reschedule. And later you head to the gym, running on a treadmill, which is allowing you to, later you head to the gym, your glasses sync with the treadmill, showing you statistics and making it possible to do basically, oh, now I'm lost, sorry. To run together with your friend and their avatar, there we go. On the way home, you finally want to stop by the grocery store, and as you enter, you're reminded of that one recipe your flatmate sent yesterday, the one with roasted vegetables and with quinoa. Your shopping list populates with ingredients you don't have at home. Because remember, the computer knows what's in your fridge because you previously gave it permission to track that context. As you walk through the store, items on your list highlight gently when you're near them. No need to pull out your phone, unlock it, or open an app. Check the list. The information is just there when you need it, where you need it. You finally head home and enjoy a nice meal with your flatmate undistracted. To those of you who close their eyes, please open them now and become fully present with us. Having pitched this future to many of my friends and colleagues, most seem to agree that this is something we should aspire to. Yet only a few believe that we're actually moving towards it. Most see our future like this. It seems that modern AI companies are more determined to shoehorn their technologies into our existing paradigms and create a overstimulating metaverse than to actually envision a new user-centered future and design economies that also support it. So for this final section, I want to share 3 fundamental design principles that could bring us closer to this utopian scenario. Then I'll propose a systems architecture that puts this into practice. Principle 1 to me says content should appear where and when it's relevant to the physical and social context you're in. You should not have to open an application window and navigate to the relevant chunk of the interface yourself unless you really want to achieve something that is completely disconnected from the space you're currently in, like reading news or sending messages. This requires designers to think which information they'd like to present in which context. And it's actually a great exercise you can apply right now to your own work. If you had a surgical knife and you could cut out parts of your existing 2D interfaces, where would you place them? And when would you present them to your users? In our day in the life example, fitness data appears near the treadmill, your shopping list anchors to the basket, and documents span your office table. The cool thing about extended reality is that we can fully manipulate people's perception, which opens up new possibilities, like presenting interactive 3D models or highlighting and dimming real-world objects to gently direct focus. Principle 2 says actions performed by the computer should always realize some user intent. This intent could be predicted using cognitive models or inferred from the user's movements, depending on the conceptual level. Traditional interfaces force fixed rituals, like a press, a swipe, or a command with your voice. But when actions realize intent, you gain flexibility. If you want to, some things can happen automatically. Others you might trigger explicitly through whatever feels natural to you. As an exercise, again, think about all the things people can achieve using your product or service, and try to formulate these as if-then triggers at an appropriate level. In our day in the life example, a transit ticket is purchased implicitly by entering the tram. Items are checked off your shopping list implicitly by putting them into your basket. Your Pomodoro timer sets itself once it notices that you're trying to focus on work, but you are still the person scheduling emails with a hand flick, highlighting passages in papers by sliding over the table, or typing your talk script using a software keyboard. Principle 3 says content, especially immersive content, capturing plentiful attention, should be shareable with people nearby and over distance. Computing has been intensely individualistic in the last decades. Everyone staring at their own screens, even when sitting next to each other. But the vision of ubiquitous computing requires computing to weave itself into our shared reality. I think with extended reality, this aspect is often overlooked, maybe because the first picture people have in mind is that of someone wearing a VR headset and dozing off. In our day in the life example, the professor's educational model appears physically in the classroom, allowing all students to see and interact with that one instance. And when you were racing your friend in Bucharest while running in Zurich on the treadmill, you're sharing an experience across the distance that feels way more present than a video call. So what about the computing platform has to concretely change for these design goals to become feasible, economically viable, and for people to accept and trust a device they wear 24/7? Let me propose a system architecture that might get us there. Traditionally, we interact with apps that internally use the operating system to access sensors and resources like files. They take over the entire screen and consume all input when focused. But what if we turned this relationship around? What if we primarily interacted with the operating system and accessed apps through it? At that point, we might as well call apps abilities, since they add functionality without claiming space on their own. This leads me to my final recommendation. Build intelligence into the operating system and content, actions, and domain specifics into the ability. This helps with three things. First, it democratizes access. Who here has developed something with AI or some intelligent feature before? Can I see? Oh, many people. Every app developer right now who wants these features needs to build or license understanding, human sensing, and human modeling, and that's expensive and redundant. If we shift this to the OS, it gives all developers a level playing field. A meal planning ability shouldn't need its own object detector. It should just provide domain knowledge like ingredient databases and recipe substitutions, and the OS handles the vision and reasoning. Second, it improves user experience through personalization. A head-worn computer is something intensely personal. This architecture lets users pick and choose what to show and how to control it. For instance, a person with motor disabilities might prefer mouse automation or gaze-based input, and a blind person might prefer to listen to audio descriptions of content. The system adapts to the individual needs. And finally, it enables fine-grained privacy controls. When you install the recipe ability, for example, you can explicitly grant it access to only your fridge contents. It doesn't get your messaging history, it doesn't get your gym location, just the context it needs to function. This increases trust, which is important for adoption. So you might say, this was a nice excursion, we have been dreaming, but how does this help me today? Not just in 10 years. Why even think about post-screen futures? Well, what is at the core of all these principles still holds true today, and thinking about them can make you a better developer and designer right now. Sure, you might not be the developer of the next big operating system, but you can advocate for user, task, and context-centric developments in your company. When designing your next feature, ask, are we designing for explicit actions or user intent? Is our content locked behind frivolous navigation, or is it contextually accessible? And are we building for individual screens or shared experiences? Even in today's app-centric world, you can expose your app's capabilities through Model Context Protocol or app intents. You can design for multimodal input, implement granular privacy controls, and you can, of course, contribute to or use open source XR and AI foundations. Let me again leave you with Hornbeck's definition of HCI's driving question. How can people with different goals and capabilities in different contexts be able to use computing productively, enjoyably, and safely? That's the question that should guide us, not engagement metrics, not time of platforms, but genuine human capability and joy. The next era of computing could be one where technology finally becomes calm, where interfaces disappear and computing augments rather than interrupting us, where we move from apps that compete for our attention to abilities that enhance the human experience. It's up to us whether we reach it. Thank you very much. I'm open to any interesting thoughts on this, since it's such a futuristic idea.